Okay, so on the previous class we were writing code for a menu using do while loop, and we had created these three functions: prompt user, display menu, and execute menu. And from main we call the prompt user function without any parameters, and this function has a loop that will continue until choice is 4. So while choice is not 4, it keeps on looping. It'll display a menu for users. We prompt the user for a menu choice, and then we can process the menu choice. Okay, so last week we were saying that maybe we could do this, but maybe we should let this execute, and then we go ahead and allow for case 4 here, and then we say you chose to exit instead of having this conditional statement here. And now our code looks a lot better, it looks cleaner. All right, so and then we can execute this program. Click on CMake and examples for do while, run in terminal. Let's test 4. So we chose to exit, and then the program exits. Up arrow, enter. Option 1, option 2, option 3, and then program exits. Notice how we don't have test cases for the menu. So the question is, well, when do we write test cases? For the menu, like, the risk for not writing a test case is low, meaning like we're not dealing with super sensitive data, for example, like financial data or bank data. So if we are dealing with menus, then we can probably get away with testing like I just did. But if we are writing code that calculates numbers, then we need test cases, right? We don't want to take that risk that our code will produce invalid results. So that's just food for thought. Okay, so any questions with what we just did? Okay, so while y'all are thinking, and then last week I think I went in here, and then I purposely did more or less the same thing that we did with do while, but I did it in the for loops main, just to show you how breaking down a program with functions, right? This is without functions, and notice like it's kind of like just a lot of code, and it looks busy, and even though it's a small program, it's already like getting too big. And if we come back and look at the do while, well, I mean, main is super small, and then prompt user depends on 2 functions, display menu and execute menu. But look at how our code is easy to follow, right? So we have a choice with display menu, we capture a choice, and then we execute the menu choice, and we keep on looping until choice is not 4. I mean, choice is 4. So and then we can see the function code here for display menu, and then we can see the function code for execute menu. It's the same code over here, well, barring the if else if, right? But it's the same code, but the do while and the use of functions allows us to create a program that in the long run will be a lot easier to maintain. Like if you're a programmer, you don't want to see code like this, especially if you have to maintain it, because then you get into the fear of, well, what if I change something and I break something and then I don't know how to fix it? And that's what happens like when there's no code structure with functions. But once we break down a program with functions, and then we have confidence that we're just working with a snippet of all the code, and if we make a mistake, then it's in that piece of code that we're working with, right? So, and that's what we're getting into today, like functions. I know we've discussed functions, and we've used functions since the first week of class, mainly for the use of test cases. But functions allow us to do what we just did here. Like, it allows us to break down a program into functions. And then it allows us to focus, like if we're working with this function, then we know we're only working with the display menu piece. If we're working with this code, then we know we're only working with the execute menu piece. So it allows us just to focus on one section of the program. And that process is called divide and conquer. And then this process here compared to this process, right? Like, you notice here how there's all this code. But in this main, what we are doing is we are encapsulating, or we are hiding away the details of our program. And that's the divide and conquer approach with encapsulation, or hiding our code behind functions. And it makes it a lot easier for us to work with. It also allows us to reuse code. So when we write functions, right? So we can create functions in a manner that we can reuse them in other pieces of our program. But if we code like this, like everything in main, and we want to reuse a piece of this without functions, then we are left with copying and pasting, which will work. But now we have two sections of code, or maybe three if we use it 3 times, that we have to change if we have to modify the block of code that we copied and pasted, right? And more than likely, if we do that, we're going to forget that we copied and pasted further down the line, and we're going to run into problems. So another reason to use functions. And finally, we know that functions we use because they allow us to unit test, and these are functions that return a value. We can create test cases and write require assertions to make sure that the code we are producing works. Why do I make students write test cases from the beginning? Because if you pay good money to take like a 1 week code camp or a code crash course, and the first 4.5 days they show you how to write functions, how to write classes, how to write a list of classes, how to create your own data types. And then Friday afternoon, they introduce unit testing. Then you're going to have the conception that, well, maybe unit testing is not that important. Otherwise, they probably would have devoted more time to it. But unit testing is important, so we have to introduce it as students are learning how to program, because number one, you create code that works, and you have confidence that that code can be changed by you or someone else in the future, and you won't be breaking the build, right? So here and I'll explain what that means. Here you're just writing code for your assignments. But this workflow that I teach you will work for 1 or more developers. So if you're working in a shop that has 10 developers, all of them are working on a feature of a program, they cannot check in their code unless a senior programmer reviews the code with them and makes sure that they code to the requirements. And more importantly, they make sure that the code builds and runs and does not break the main code, right? So the main code has maybe like, I don't know, I'm going to throw out a number, right? 10,000 lines of code. You write 100 lines of code. So you want to make sure that those 100 lines of code don't break or mess up the 10,000 lines of code, right? So that's why unit test cases are very important. So Let me see here. Was it 4? Yeah. Let me go to the 4.h. Any questions? Okay, so no questions yet. Okay, so that was the reasoning for functions, right? What are those 3 reasons? The book talks about divide and conquer. I added hide away our code, encapsulate, code reuse, and unit test cases. There are 2 types of function in C++, just like there were 2 types of functions in Python, right? A function that does not return a value, like this one, void display numbers. Whenever you see the keyword void, that means this function does not return a value. Notice here in the code, there is no return statement. When you see a function that has a data type here instead of void, that means the function returns a value. And in those functions, you have to include a return statement, and you have to return preferably the same data type. You can return other data types, but C++ will convert up or down, right? So you may lose numbers or digits, and then your program will produce invalid results. So preferably, it's always better to return the same data type that we said we were going to return. Questions on the 2 types of functions? Okay, and then a function, as we know by now, can have no parameters, or it can have 1 parameter. It can have 2 parameters, and the data type can be different. So we can do that, and we separate the parameters with comma, okay? So it's complaining that we don't have a code for that. Any questions on parameters? So what do parameters help us with? So when we write a function, the parameters are rules that we set for our code for users of our functions. A lot of the times it's us, but sometimes it may not be us. Like you might be creating code that other developers use. Maybe you're creating code and other developers use your code to get data, and then they display that data on a Windows front end or on a web front end. So the parameters clue you or other developers, and they let you know, okay, so if you want to use display numbers, then you have to provide a data type of int. And if we have more than 1 parameter, then they have to give us data for each parameter. If they don't do that, then the code doesn't compile, and obviously they can't use our function. Likewise, if we want to use another developer's functions, we have to follow their rules. So we have to look at the function header and then make sure that we send the appropriate data types for each parameter. Any questions here? Okay, no questions. So for example here for sum of number, some students in homework assignments were getting confused, like how do I send data? Let me open the 4.cpp. How do I send data to my function? Well, one thing you don't want to do is, this means someone's going to give me a num. So it may be you, it may be someone else. And how are they going to give us data? They may call the function sum of number, and they provide a variable. And this variable has the value that we capture from the keyboard. Other times, you might get data from some other function, assuming this some other function existed. This some other function executes and saves the value to num, and then we can use num here. Other times, if we are using a test case, not this one, then we provide values with literals. Like we literally go in here and type the number. Like we know if I use sum of squares with the number 3, it should return 14, and so forth and so forth. So that's important to understand. Questions here? Okay, no questions. So that was function parameters. So the next topic is the variable scope. So let me go ahead and close this one. I don't want to save any changes, and then go to main.cpp. Let me see here. Okay, we're gonna focus on this code right here. And let's review what sum of squares is. Sum of squares accepts a number, and then it tabulates the square of each number, saves it into an accumulator, and then returns it, okay? This is num. What I will purposely do for now is, instead of value, I will change this to num. And I think that should be okay. And then I will purposely change this variable name to sum. And I have to change this one too. Okay, so I do that because if we go and look at our function code, we have num here and we have sum here. So I want to make sure that everyone understands that this num and this sum, they're the same as this num and this sum, or they are different. What do you all think? So we have Adrian and Irvin, right? So they chime in. So one says different, one says the same. So the correct answer is that they're different variables. But I think to clarify this and to drill this point home, we go ahead and create a memory diagram for this. So for this diagram, pay attention, because your assignment today, your class assignment, you create a memory diagram too. So please make sure that you understand this. So variable scope. So we have function variables, and then we have global variables, right? So we can have num, which is a function variable belonging to main, and we have num, a function variable belonging to sum of squares. And then we can also have a global variable, but these ones are highly discouraged. So I just mentioned them, but don't use them. The only time we want to use a global variable is maybe if we want to create a read-only variable, like for the tax rate, like we did for the assignment last week, then that's okay. But we have to make sure we make it constant. That way no one can change it in code by mistake. Okay, so we're going to focus on int num and int sum equals sum of squares. Okay, we're going to focus on that value. And we are going to assume, to make it easier, that these statements don't exist, and we're going to say that the value here, we set it to 5, just to make the example simpler. Okay, so let me come over here and let me int main, and okay, so we have, I'm not going to write all the code, right? I just want to focus on int num equals 5, and then let me go and see the code again, and then I want to focus on this statement here. So what I'll do is I'll purposely create sum but not assign it a value, and then the next statement will be sum equals sum of squares. I don't want to write it all, okay? And then we pass in the num as a function parameter argument, and then we go ahead and diagram this with the stack memory. We know there's a heap memory, but in this example we are not using heap memory. Okay, so this will be like some large number, ends in 4, 2, 8, and 12. Okay, so when this statement executes int num equals 5, the value is stored here. When the next statement executes int sum, we get this address blocks from 5, 6, 7, 8, right? So we get 32 bytes. There is some value there, but we don't know what the value is, right? We just asked the operating system, hey, give me a variable space for sum, and it's like, okay, there's your space. And then we ask C++ to give us that space, right? So then the next statement is sum of squares num. This piece right here, the function call executes first. So if we go back and look at the code, sum of squares needs space for num, and it needs space for sum. Okay, so let me use a different color. So the function num variable gets what value? Let's go look at the, well, we can trace the code here. Int num equals 5, sum of squares with the value that the variable num holds. So then we can say that this one is 5. So notice the function parameter argument num right here gets its own address, and the main num equals 5 gets its own address block. So we have two num variables, one belonging to main, one belonging to sum of squares. Okay, and then while that function executes, we also get space for sum of squares sum. Oops. And let me see, I think we set it to 0, right? Set it to 0. So the initial value is 0, and that one will be some large number ending in 16, right? Questions so far? y4, y4, y8, y12, y16. So y is like some large number for addresses, but this is the address number that the computer will allocate to C++, right? So since we are working with numbers, integers are stored in 4-byte addresses. Not 4-byte, 32 bytes, right? So we have 1, 2, 3, 4, right? So 8, 8, 8, 8, 32 bytes. So, 4 bytes, 32 bits, sorry. So that's what this stands for, right? So, and all of them are dealing with numbers, so that's what we skip in 4s, 4, 8, 12, 16. Yes. So Tabitha, yeah. So in num is from main, gets its own address. Sum gets its own address, it's from main. And while the function executes, there's a space for the num, this num right here, this num, okay? And then there's a space for this sum right here, which are this one and this one. So yes, it duplicates them. So it creates a copy. What does that mean? So if I go here and I'm like, well, let me mess around with this stuff. Num equals 10 in the function, which address will be modified to 10 or updated to 10? The blue one, right? This one. Yes, so this one will be modified to 10. And this one will keep its original value 5. So this is important to understand because sometimes students, when they see num here, and then they're like, oh, and then they see num in the function, sometimes students think it's the same variable, but it is not the same variable. And please make sure that you completely understand this concept. So it creates a copy. Likewise for sum, right? So this is main sum, and then this is sum of squares sum right here. Yes, we are changing the function value. So other questions? So then the question that I have for you all is, when does this sum get a value? This one right here. And what value will it get? Yes, right there when it is assigned, but what is happening? When the function is called? Okay, can you elaborate a little more on that? So we can go to the function, right? So the function's called. And for now, like we'll leave this here too, right? So when the function executes, yes. So the function is executing, and then we tabulate sum, we change num to 10. So while the function is executing, we change, let me get the blue color. We change this one to 10. Why? Right here we are saying function sum of squares num equals 10, okay? And then we say return sum. So we're not saying main sum equals sum. So we are saying return sum. So then it means, what does that mean? So we know that this guy is going to get a value. Let me change to green. I think the answer was 55, right? 55. So that one's going to have 55 after the loop exits, right? So the loop executes, is accumulating, and when we're here in this statement, or even here in the return statement, sum's value is 55. But then we return. So what does it return? Returns sum. Sum is 55, so right, so when function exits, it gets that sum value and stuffs it into the main. And then this one becomes 55. Once the function exits, our program no longer refers to address 12 and 16, meaning the values are still there, 10 and 55, but our program can reuse those address cells for other variables. So sometimes what we do is we just do this, right? Just to make sure that we understand that, yeah, the value is there, but our program doesn't refer to them anymore. Why? Because sum of squares num and sum of squares sum only exist while the function executes. Some values change each time the loop run, but it saves it in memory each time, but I just said that sum, when it got here, it was going to have the value 55. Like, I didn't go through each iteration and set a value. But yeah, like, while it's looping, sum's changing, but I didn't want to go that into detail. Like, I'm just interested in, at this point, like, what's the value of sum? It's 55, right? So, yeah. Hold on. Okay, so everyone understands this? This is very important because the next class we're going to learn of a different type of function parameter that differs from the one we're talking about here. So it's important that we understand this. So here we're talking about variable scope, and I just want to make sure that everyone understands that this num is different than the function num, and sum is different than the function sum. So since the stack is last in, first out, the first variable that'll be eliminated is sum and then num, right? Because last in, first out. So any other questions? Okay, so what we can do, just to make sure that we validate what we just diagrammed, is we can run the code. Okay, so we come here. So this is sum of squares, num equals 10. So what I can do here is IOStream. And then I can say sum of squares num value before we change it, right? Before changing it, num. And then we say sum of squares value after. And then we will come over here and we'll say main num before function call. Which function call? this one, sum of squares, right? So let me go ahead and add a new line here. And then we say, let's go ahead and main num after. And I think I need to include new line character here too. And here too. We just want to prove that our diagram's correct and that they are indeed two different variables, okay? So if they were the same variables, then num after the function would be called would have the value 10, right? So we better see that num is 5 here and that num is 5 after the function call too. So let me go ahead and run this. This is 0, 1. Okay, so we come here, run in terminal. Okay, so let me see. Main num before function call, 5. Sum of squares num value before is 0. Why is it 0? Because we are decrementing, right? So it won't have the value 5. Maybe right here we should have put an output before the loop, but let's understand that it's 0 because we were decrementing, okay? And then let me go back to the program. Sum of main num before function call, 5. Main num after function call, 5. So we did change a num, but it was a num that belongs to the sum of squares function scope. So meaning, yes, they are two different variables. Questions? Again, this is very important to understand because we're going to learn about reference parameters and reference variables in the next class. But if you don't understand this, then the other types of variables are going to confuse you. Okay, there's a diagram. So for the homework assignment, make sure that you want, like for example here where I was saying that when the function is exiting, the value of the sum of squares sum is going to be copied over to the main sum. Make sure that you write something like this. Like when function exits. That way, make sure that you're understanding what's going on in the program. And then also, like once our program exits, our main program exits, then this address here and this address here are no longer going to be referenced by our program, because our program is not in memory anymore. And then the operating system can assign those addresses to some other program that's running on the OS. Okay, is the diagram okay? I'm done. Okay, so let me go back to, so this is the sum of squares code. I just added the cout, the num equals 10, and the cout, right? Just to show that they are two different variables. And then in main, I did the same thing just to show that we are not modifying the main num. So we do cout before the function call, we call the function, and then we do cout after the function call, just to show that we then modify the variable num that belongs to main. Okay, so let me see, what is the next topic? So static variables, I don't write an example for that one, mainly because we want to know they exist, and you might run into static variables in any language, right? Actually, I don't know if Python has static variables. I know C# and Java do. It's a variable that's created and persists for the lifetime of our program, meaning while our program runs. They're not variables that exist, like for example, sum only exists while this each and every single time that sum of squares is executed. A static variable will exist for the lifetime of the main program, meaning as long as the program runs. So if you're accumulating and say you just want to have a counter for every single time that a function is called, then you would create a static variable and increment it every time the function is called, and it would persist for the lifetime of our program. Once we shut down the program and then we restart it, then whatever initial value we give it, that's going to be the value that it has. So the book talks about them. So if you want to see the example for those, then look at the Gaddis book. And I think the free book also mentions them. I don't have an example because we want unless you really have to, you stay away from them, right? So okay, so the next example is default arguments. So I think for this one I will create a new example, and we create it here in value and reference parameters. Value and reference parameters. So we'll create a very simple function, get area, and we go ahead and open the value ref CPP file. And this function, really all it does is return height times width, a very simple function. So we understand from parameters that anyone who wants to use our function getArea must apply height and width values. They have to, like, there's no way they cannot include them for us. If they try to skip them, the program will not compile. So let's see here, test get area default parameters. Right now, the way we have our function written, I think I have to include value ref up here, right? So include value ref.h. The way I have my function written right now, if I want to use getArea, I have to provide some values. I have to. I mean, if I don't, then my program complains, right? Because Visual Studio Code's like, oh, there's something wrong with your code. And if I want to get away and be sneaky and be like, well, maybe if I just don't provide any parameter values, then it'll compile. No, look, as you can see, like, we have to go this route to get our function to work. There are times that we want to use default values. So what we can say is that if they don't provide a value for height, we want the default value to be 20. And if they don't provide a value for width, then we want the value to be 10. What does this mean for our function calling? It means that now I can come over here and call getArea with no parameters. And the answer we expect is 200 because we say that height is going to be 20 if we don't get a value for this parameter, and width is going to be 10 if we don't get a value, meaning the default value that we assign to these variables. And we can try to execute this. So we come here, run in terminal. Well, actually that's the program, right? So Control C, want the test case. Run in terminal. And it's building. And it's still building or linking, so almost done. And everything's green, which is good. Up arrow, space, dash S, enter. Let me get some more room up here. Okay, so we are interested in test get area default parameters. Passed, get area with values 5 and 5 as parameter argument values for height and width equals 25, and that passed. And if we don't provide any values, then it reverts to our default height 20 and width 10, and we get the answer to 100. So that is the use of default parameters. And can we do, I guess, some other assertion? What do you all think? What else can we try to test here? One parameter with default, right? So let's see. Okay, so require get area with 5, and what do you all think that's gonna give us? $50, right? So we come back and look at our code. So if we say 5, then height gets the value 5, and then we don't provide a second parameter argument value, so then width is going to default to its value 10. So then we can say that that should be 50, and then we go ahead and run it one more time, run our test cases again. And it's building. Any questions while the test cases are being executed? Any curious questions about calling the get area function? Up arrow space dash S, enter. So then our test case passes 2, meaning like, yeah, so 5 is assigned to height, width keeps its default value of 10, and that produces 50, so our test case passes. Questions? Yeah, there's no way to assign a value to the second. Yeah, there's no way to do it. Because then, and I think some students were like, what if we put get area and then comma and then like some number? But we can't. So we would have to, if we wanted to keep 20 as the height's default, then we would have to say like get area 20 and then provide a value for the width too. So there's no way, unless we would add a third parameter, but then that wouldn't make sense, at least for this function, right? A third parameter would not make sense. Yeah, you would have to pass values yourself. Meaning for the two, like we did here. 5 and 5. And if you wanted to keep the default for that one, then you would put 10. Actually, the other way around, right? 20, 10. But there's no way to pass a value. Because then, like, how would the compiler know that we're talking about the second guy? So it always just defaults to the first one. Right? If we only pass one value, then how does it know that it's this one or this one? So then when they coded this default parameters, they're like, well, we're just going to default to the first parameter. And that's the way it works. I think that's the way it worked in Python too, if I remember. Oops, that's not what I wanted to do. I wanted to come back over here to, okay, I feel like that. Well, yeah, but it doesn't work like that. I mean, I don't know why. I don't know why they opted not to, but yeah, that could work. Okay, so one last topic I wanted to cover was the code reuse and the divide and conquer. So I want to go into how we structure our programs. Like, for example, if we look at this test case that we just wrote, we include value ref, and then we can use the get area function here. And if we go into the CMake list for value or example 5, we can see here that we're saying add library, name it EX0405 library, use value ref, CPP, and age to create the library. What does that mean? Right, so come back here. So we know that C++ has the core language, and then C++ also has the standard library, and we can use keywords from here. We can use objects or functions from here to use in our programs, right? Say, so we can use those in our program. But every single time we create a library, we're creating like our own library. So, and that falls under the category of user defined library. And we can also use those in the main program. And that's important to understand. So this is example 0405. Let's look at the CMake list for our test case. EX04 test. So we're saying target link libraries. And if we come back and we have 1, 2, 3, 4, 5, 6, 7. So we're like 1, 2, 3, 4, 5, 6, 7, and link them to test. So that's how this piece works, because we're telling the compiler via CMake, like, you can use code that we have created ourselves. Let me go back to the diagram. and this would be examples 0401 through 07, our own user-defined libraries. And that's how the test cases know that that code exists, and it can call those functions, and we can use them in a test case. And the same thing holds for the main, but in main we're just telling the compiler, like, create the executable, use main.cpp and the value ref.cpp to find the code. And in main.cpp, recall that we include, well, not in this case, but we want to use code from here, we have to include value ref.cpp, and that's how everything's linked together. So in essence, we are creating our own user-defined functions in our own libraries. Questions? And that's how we can make this happen, right? Code reuse, unit testing, and then at the same time we divide and conquer and hide away our code with encapsulation. Questions on this? Make sure you understand this, because you'll definitely see this in a quiz. Okay, so do we add and remove from this standard library when we comment out at subdirectory? Yeah, so every time you comment out something in the CMake list, that you would be excluding it from our user-defined library. Yep. Okay, so let me see here. I'm thinking whether I want to start on the next topic or not. So we discussed this piece right here, variable scope, and what I wanted to point out here was that they're not the same. And I think we more or less understand this. What I want to discuss now is what type of parameter. Let me go back to the while, okay, because that's what we were discussing. So this is a function parameter. If we had to give it a name, what name would we give it? Like, knowing what we know about it. Let me go back to the diagram. And on this one, I will stay mute until someone either guesses or more or less guesses a correct answer. So I'll wait for you all's responses. No, what type of function parameter, or what would we name the? So we know this is a function parameter. The variable is num, but the technical term for this one is a function parameter. Knowing what we know from this diagram, what can we name that function parameter? Not the variable, but the function parameter. And the clue is in address 16 and address 8. No, we're not talking about renaming the variable. So we know that this concept here is, the technical term for that is function parameter. So we're not talking about renaming the variable. I'm talking about if we want to give a name to function parameter, not the variable, just the concept of a function parameter, what would we name it? Yeah, because if we name it num param, that doesn't make sense, right? So just forget the data type. Like, just think of the concept of a parameter. This could be double, this could be char, this could be bool, our own user-defined type. So we can't link it to the name, right? So we know that this is a function parameter. How can we further describe it, knowing what we know about the diagram? And I'm saying the clues is in address 16 and address 8 there in the diagram. Yeah, the function's input. Again, the clue is in address 16 and address 8. Like, what's happening there? When does address 8 gets its value? Yes. What is happening? Yeah, Adrian's on the right track. So a migration parameter, something else maybe. We're close, like Adrian's on the right path. A function migration parameter, function return value. Just read Adrian's chat, and from there look at Y16 and Y8, and then we're on the right path. Like, we're very close to getting the answer. Whatever we pass in the function is assigned to num. Return value, data value, migration parameter. What's another word for migration? Maybe like a better word that describes what's happening between assigned. Well, it's assigned. We know it's assigned, but it's so an assignment parameter. Any more verbs here? Migrate, assign, transfer, or close. Copy, right? So it's copied. So they are known as copy parameters, but the official name is that C++ uses is value parameters right here. So this concept right here where we pass in a parameter and then we don't modify the value. Instead, some process of copying happens, so then those parameters are called copy parameters. But I said Y16 to Y8 just to talk about the copy thing, but what's really copied is this value here from int num to this int num, right? So they are copy or transfer. They're transferred, but the word is copy parameter, and the official name that C++ uses is value parameter. So again, we have the value 5, and we say, hey, use variable num as your parameter, but that value is copied, right? So questions? Replace that. So the official name is value parameters, but if you hear, even in C# or Java, like if you hear like pass by value or pass by copy, then you know that they're talking about a variable that is not modified within the function. And on the next class, you will be introduced to another concept known as a reference or reference parameter. So we'll introduce references, and then we'll talk about reference variables, and then we'll see how reference and value parameters differ. And for some reason, some students understand the concept, but other students are they bad or something? Actually, so value parameters are not bad. Like they use, like that's the recommended method for passing values to functions, as long as a value small, like an integer or a character bool string, right? We wanna. It's okay to create a copy, because I mean, how long does it take to copy the number 5 into here? Like milliseconds, probably nanoseconds. But what if we have a variable? What if this num, instead of an integer, is like a list, or in C++ it's called a vector, and it has maybe like 100,000 items, meaning it'll take a lot of these address spaces. So in that case, it's probably not a good idea to pass them by value or by copy, because now we're going to have the same list in 2 different places, and our program is not using memory efficiently. So that's why we need a different type of parameter, which we'll talk about in the next class. They're not bad. What is the significance of them not being changed? It's for data protection, right? Because we don't want, like, let me go back to main. Like if we say num here and we pass it into the function here, and say the value concept did not exist, like this value would be changed in here, then nothing's stopping us from corrupting our data with something like this, like maliciously or by mistake, right? So that's why value parameters are used to keep us from shooting ourselves in the foot. So that's why, like, the copy's passed, and even if we think we're changing it in the function, this is the integrity of this value is kept, so we don't, variables kept, so we don't modify it. Yep, you're correct, Richard, and we'll talk about that on the next class. Like, and that's what a reference parameter is, and we'll discuss and learn about reference variables. Okay, so that's all I have. The assignment should open at 7, but let me go ahead and open it right now. And if you're paying attention to the memory diagram piece, then you should have no issues finishing the homework. Let me go ahead and make sure that I unlock it, because it's not available yet. So where am I here? Course content. Yeah, so next week we'll still be talking about functions. Assignments. Maybe by the time I open it, it'll be 7. So edit. Available at 6 p.m. so that it can be open. So if you're in the calendar, refresh the calendar. If not, log into Blackboard, hit the calendar, and you should see assignment 3. And it's due at 7:25 today. Shouldn't be too difficult for you. I'll stop sharing. Are there any other questions? Okay, the assignment should be available. So.